Solving systems by substitution, part 2. Now that we've had some practice solving systems using substitution, where either one of the variables already said y or x equals, or both of the variables did, now we're going to look at some problems where neither one of the variables say y equals or x equals to start. When we have this case, we need to get at least one of the equations to say y equals or x equals. I always choose whichever one is easiest to manipulate. So, in the problem above, 2x plus 2y equals 10, and 3y equals 6x minus 3. If I were to try to get one of these to say y equals or x equals, I would probably use this second equation. And so I'm going to manipulate it so that way it will turn into a y equals. And so we start with 3y equals 6x minus 3. And to manipulate this, I divide it by 3, divide by 3, and divide by 3. And I'm left with the equation y equals 2x minus 1. Now that I have one of the two equations saying y equals, I can use substitution and fill in 2x minus 1 wherever it says y in the first equation. To do this, I would just take my first equation that says 2x plus 2y equals 10, and I would substitute in and get 2x plus 2 times, now I'm going to substitute, 2x minus 1 equals 10. At this point I could solve, and so if I solve here I'll get 2x plus 4x minus 2 equals 10, which is 6x minus 2 equals 10. And I could add 2 to both sides and add 2 to both sides, and I'd get 6x equals 12. I'll rewrite that here off to the side. 6x equals 12, divide by 6, and I would find that x equals 2. Now, I could have, if I had wanted to, if I liked the choo-choo train method better, I could have turned both equations into y equals, and that second equation again was 2x plus 2y equals 10. If I wanted to turn that into y equals, I'd subtract 2x from both sides. I'd get 2y equals negative 2x plus 10. I would divide by 2, divide by 2, divide by 2, and I find that y is equal to negative 1x plus 5. In this case here, now that I have two equations that both say y equals, I could use the substitution method to get 2x minus 1 equals negative 1x plus 5. Now I'm going to solve this, and what I should still get when I solve this problem is I should get that x equals 2. So let's rewrite here. I'm going to use the space above, and we're going to rewrite, and we're going to get 2x minus 1 equals negative 1x plus 5. And I'm going to add 1x and add 1x, and I'll get 3x's minus 1 equals 5, add 1, and we get 3x equals 6, divide by 3, and once again we get x equals 2. It doesn't matter which method we use to solve. Either way, we still got that x was equal to 2. Now we have to remember, we need to take this and plug it into one of the equations to find out what the y value is. Alright, so my equation was 2x plus 2y equals 10, and we found that x was equal to 2. So we're going to solve this, plug this back in to find out what y should be, and we'll get 2 times 2 plus 2y equals 10, and 4 plus 2y equals 10, minus 4, 2y equals 6, divide by 2, and y equals 3. So my solution is x equals 2, y equals 3. The point 2 comma 3 is the one point that satisfies both equations. So let's try a couple. So I have 3x plus y equals 7 and negative x plus 2y equals negative 14. Looking at this problem, I see that one of the problems already has y all by itself without a coefficient. So I would probably just turn that equation into a y equals. So we'll take the 3x plus y equals 7, and we'll turn this into a y equals by subtracting 3x from both sides. In this case, I get y equals negative 3x plus 7. Now, I'm going to take this and substitute it into the second equation, and the second equation says negative x plus 2 times whatever my y was, and my y was negative 3x plus 7, and altogether that equaled negative 14. I'm going to distribute. I get negative x minus 6x plus 14 equals negative 14. Negative 7x plus 14 equals negative 14. Subtract 14 from both sides, and I get negative 7x equals negative 28. Divide by negative 7, divide by negative 7, and I get x equals 4. Now we got to remember, we got to substitute it back in to find out what y needs to be. So I go back to my original equation, 3x plus y equals 7. I plug in the value of 4 for x, plus y equals 7. And so 12 plus y equals 7. Subtract 12, and we find that y equals negative 5. I can test this by, once again, substituting into my other equation, which was negative x plus 2y equals negative 14. And I'm going to substitute the x and y in, and this is negative times the x value of 4 plus 2 times the y value of negative 5 has to equal negative 14. And I find that this is negative 4, this is negative 10, must equal negative 14, and negative 14 does equal, in fact, negative 14. Alright, so let's try another one. This one says 2x plus y equals negative 2, and negative 2x plus y equals 10. I'm going to give you a second to try to solve this. You can either turn one into y equals, or turn them both into y equals, and solve. If you'd hit pause here, work out the problem, and then come back, hit pause again, or play again, and watch for the answer, and I will have worked out all the work. Alright, so you should have, or I actually did, took both of them to y equals, and so I got one equation that says y equals negative 2x minus 2, and another equation here that says y equals 2x plus 10. I set them equal to each other and got negative 2x minus 2 equals 2x plus 10. I solved for x, and when I solved all the way down through x, I got x is negative 3. I subbed the negative 3 into the first equation and wound up finding that y was 4. And I subbed it into the second equation and also found that y was 4. Therefore, my solution is negative 3, comma 4. So let's try one more. 2x equals negative 2y minus 12, and 3x plus 9y equals negative 45. You may solve this any fashion you want. Please hit pause, and when you're ready to see the solution, hit play again to see the solution. Alright, for this problem, I took the 2x equals negative 2y minus 12, and I solved for x, and I got x equals negative y minus 6. I then plugged the negative y minus 6 into the second equation, And when I solved for y and found that y was negative 4.5. I solved this back into the equation x equals negative y minus 6. And when I solved, I found that x was equal to negative 1.5. To check my work, to make sure it worked in both equations, I took the second equation, the 3x plus 9y equals negative 45, and I subbed in the x value and the y value. When I distributed, I got negative 4.5 minus 40.5 equals negative 45. And when I combined, I did find that negative 45 was equal to negative 45. So therefore, my solution was x is negative 1.5, comma, negative 4.5. I hope this helps, and now you need to proceed on to your next assignment.